Hello, everyone. In this session, we're going to think about the May 2026 Theory of Knowledge Prescribed Titles one by one. For each, we'll define the core ideas, explore arguments and counterarguments, and connect them to real examples. Title 1. In the production of knowledge, does it matter that observation is an essential but flawed tool? Discuss with reference to the natural sciences and one other area of knowledge. Observation is both necessary and imperfect. It is the starting point of knowledge, but what we see is always limited by our senses, by instruments, and by our expectations. In the natural sciences, scientists know that observation is never neutral. A spectrometer or telescope shows us data through models and calibration. To deal with flaws, science uses replication, peer review, controls, and error checking. These methods accept that observation is weak on its own, but can be made reliable. In the human sciences, flaws are even greater because people change when they know they're being observed. Surveys show bias, and researchers can affect outcomes just by being present. This is why social scientists use multiple methods and reflect on their own assumptions. In the arts, flaws in observation can actually be useful. Impressionist painters used imperfect perception to reveal truth in new ways. Documentary filmmakers sometimes keep blurry or incomplete footage to highlight reality. So, observation matters because every AOK treats its flaws differently. Science disciplines them, human sciences reflect on them, and the arts turn them into creative strength. Takeaway. Observation is never perfect, but it matters because each area of knowledge uses its flaws in unique ways, either to build rigor or to create meaning. 2. To what extent do you agree that doubt is central to the pursuit of knowledge? Answer with reference to two areas of knowledge. Doubt is the fuel of curiosity. It keeps us from stopping too soon. But it must be balanced. Too little doubt gives blind belief, while too much doubt stops progress. In the natural sciences, doubt is formalized through falsification and testing. Newton's ideas were doubted, and Einstein offered a new model. Science progresses when we question accepted truths. In mathematics, doubt takes another form. Mathematicians doubt conjectures until they are proven. Once a proof is complete, there is no more internal doubt, but questions may still remain about the choice of axioms. So in math, doubt is temporary and resolved by proof, while in science, doubt is permanent and always open to new evidence. The danger comes from fake or excessive doubt, like cherry-picking evidence just to avoid consensus. TOK wants us to distinguish between healthy, disciplined doubt and empty skepticism. Takeaway: doubt is central when it is structured and purposeful. In science it is ongoing, while in math it ends with proof. Title 3. Is the power of knowledge determined by the way in which the knowledge is conveyed? Discuss with reference to mathematics and one other area of knowledge. The strength of knowledge depends partly on how it is communicated. In mathematics, ideas are powerful when expressed clearly. Notation and diagrams can make difficult concepts usable, like how vector notation made linear algebra practical. In ethics, communication matters even more. Ethical ideas take power through stories, arguments, and declarations. The Universal Declaration of Human Rights, for example, had global impact because it was framed in a way that inspired people. Title 4. In the acquisition of knowledge, can we only understand something to the extent that we understand its context? Discuss with reference to two areas of knowledge. Context gives knowledge its meaning. In history, context is essential. A document can mean very different things depending on the time, culture, or politics around it. In the natural sciences, context also matters. A measurement means nothing until placed in a model. A number can be noise unless we understand how it was gathered and what it represents. In mathematics, truths like 2 + 2 = 4 seem universal. But even here, context matters. In modular arithmetic, 2 + 2 can equal 0. Universality still requires a defined frame. Takeaway: understanding is always shaped by context, even in areas that try to be universal. Title 5. To what extent do you agree with the claim that all things are numbers? Pythagoras. Answer with reference to the arts and the human sciences. In the human sciences, numbers are extremely powerful. Statistics and measurements allow us to analyze human behavior, predict trends, and make policies. Yet too much focus on numbers can oversimplify complex human experiences. In the arts, numbers shape rhythm, harmony, and proportion. Music and architecture use mathematical patterns, yet art is not only about ratios or formulas. It's about emotion, symbolism, and cultural meaning, which numbers alone cannot capture. So while numbers help explain structure, they cannot fully explain significance. Takeaway: numbers reveal patterns, but they do not capture the full meaning of art or human experience. Title 6. To what extent is interpretation a reliable tool in the production of knowledge? Answer with reference to history and one other area of knowledge. Interpretation is unavoidable, but can we trust it? In history, interpretation is the very process of making sense of fragments. Reliability comes from comparing sources, being aware of bias, and adjusting when new evidence appears. In the natural sciences, interpretation is also key. Data is interpreted through models, graphs, and theories. When methods are transparent and reproducible, interpretations become reliable. But when shortcuts or biases are present, they mislead. Some might say interpretation is too subjective to be reliable. But reliability in TOK is defined differently in each AOK. In history, it means plausible explanations. In science, it means predictions that hold up over time. Takeaway: interpretation is reliable when it is methodical, transparent, and open to revision. In the end, all 6 titles remind us that knowledge is not simple or fixed. Observation is flawed but necessary. Doubt drives progress. Communication shapes power. Context gives meaning. Numbers reveal but cannot explain everything. And interpretation is always needed but must be careful. Simple takeaway: knowledge grows stronger when we question, compare perspectives, and stay aware of limits.